Hi, I am Dr. Vijay Kumar Dalla, Assistant Professor in the Department of Mechanical Engineering, NIT Jamshedpur. I am going to talk about how to draw SFD shear force diagram and a bending moment diagram BMD of any beam. Here I am taking example of cantilever beam in which one end of the beam you can see the from A to G. This is the length of the beam, and one end is left side is fixed and other end is फ्री. आप देख सकते हैं बीम के एक एंड जो है वो फिक्स्ड है और दूसरा एंड फ्री है. और फ्री एंड पे 2 किलो न्यूटन का एक एक्सटर्नल लोड एक्ट कर रहा है. ओके, नाउ आप देख सकते हैं बीम कैसे लोडेड है. सो 5 किलो न्यूटन का 1 पॉइंट लोड एट बी, 3 किलो न्यूटन का अनदर पॉइंट लोड एट डी. जी पर जो फ्री एंड है 2 किलो न्यूटन का पॉइंट लोड एक्ट कर रहा है. तो इस प्रकार से देयर आर 3 पॉइंट लोड्स आर एक्टिंग एज एक्सटर्नल फोर्स ऑन द बीम. Also there is one distributed load. There are two types of distributed load: uniformly distributed load and uniformly varying load. So आप देख सकते हैं इसका इंटेंसिटी है. Here intensity is 2 kilonewton per meter. Intensity is same. Okay. So that's why it is known as uniformly distributed load. और ये कहाँ तक डिस्ट्रीब्यूटेड है? 2 मीटर लेंथ ऑफ द बीम इट इज डिस्ट्रीब्यूटेड. एक मोमेंट एक्ट कर रहा है पॉइंट एफ पर जिसका मैग्नीट्यूड है 20 किलो न्यूटन मीटर. एंड नाउ हाउ टू ड्रॉ द SFD and BMD. So in the previous class I have discussed the section method in which we need to consider x. Assuming x, here we will not consider x, we will directly calculate the shear force and the bending moment at the each point of the beam. कैंटिलीवर बीम इसीलिए लिया गया है एज एन एग्जाम्पल क्योंकि बहुत से स्टूडेंट्स कंफ्यूज होते हैं. और जैसे प्रीवियस बीम मान लीजिए आपको सिंपली सपोर्टेड बीम हो गया, ओवर हैंगिंग हो गया, जस्ट लाइक उसी पैटर्न में इसको भी सॉल्व करने स्टार्ट कर देते हैं. तो हियर कैंटिलीवर बीम में अगर हम देखें तो रिएक्शंस सबसे पहले हमारे माइंड में क्या आएगा, या बीम दिया हुआ है तो सबसे पहले रिएक्शंस फाइंड आउट करेंगे. सो लाइक ए पी रिएक्शन फाइंड आउट करेंगे. ए पी ओनली ए पर ही सपोर्ट है. सो देयर आर 3 रिएक्शंस. एक क्या हो जाएगा, जो वर्टिकल लोड्स जितने भी अप्लाई हो रहे हैं उसको रजिस्ट करने के लिए एक वर्टिकल रिएक्शन लगेगा. एक लगेगा हॉरिजॉन्टल रिएक्शन. बट आप देख सकते हैं, यू कैन सी द बीम, देयर इज नो वन द हॉरिजॉन्टल फोर्स एक्टिंग ऑन द बीम. सो रिएक्शन फोर्स मीन्स वर्टिकल रिएक्शन देयर विल बी, बट हॉरिजॉन्टल रिएक्शन फोर्स विल बी 0. एक और हो जाएगा लाइक दिस वन. आप दिस इज द पॉइंट ए. So like this one, so this value RA at A, suppose I am taking R VA, so this value will be 0 because there is no horizontal force acting on the beam. All are vertical loads. That's why there will be this load. And also see, the beam will The beam may be deformed due to the rotation, due to the twisting. So उसको रजिस्ट करने के लिए एक यहाँ पे रजिस्टिंग moment will act to counter the moment of the beam. So in this way, so अक्सर स्टूडेंट क्या करते हैं, यहाँ से स्टार्ट करते हैं कि शेयर फोर्स ए से स्टार्ट करते हैं. सो शेयर फोर्स ए से स्टार्ट करने से थोड़ा सा कॉम्प्लेक्सिटी हो जाता है. बेटर रहेगा फ्री एंड से करें, क्योंकि फ्री एंड से करेंगे तो यहाँ पे आपका 2 किलो न्यूटन लोड है, वहाँ से स्टार्ट करेंगे. आप सपोज इफ यू आर स्टार्टिंग फ्रॉम द पॉइंट ए, सो देयर इज अ फिक्स्ड सपोर्ट, सो यू हैव टू फाइंड आउट द रिएक्शंस, एंड that is unnecessary. Why to waste our time, because our time will be limited. So that's why we must start from the free end. Okay, now shear force calculation. So from free end, and which is, this is the point G. Okay, now shear force को we are going to denote by F. So F G पे shear force क्या होगा? So by following the sign convention, like this is the beam, and हमने एक सेक्शन ले लिए लाइक x, इसको बोलेंगे लेफ्ट साइड, इसको बोलेंगे राइट साइड. So left side, suppose there will be the vertical loads, upward loads, या forces, you can say forces. So this we take positive, and downwards, this is the downward vertical load. So this we take negative. Okay, here vertical upward forces कहाँ से आएगा? रिएक्शन फोर्स से आएगा. डाउनवर्ड वर्टिकल लोड्स ऑफ फोर्सेस कहाँ से आएगा? एक्सटर्नल फोर्सेस जो एक्ट कर रहे हैं, लाइक 5 किलो न्यूटन, 3 किलो न्यूटन, 2 किलो न्यूटन, द डिस्ट्रीब्यूटेड लोड, वहाँ से डाउनवर्ड वर्टिकल फोर्सेस आएगा. ओके, सो लेफ्ट साइड, बट हम लोग स्टार्ट कहाँ से कर रहे हैं? फ्रॉम वेयर वी आर गोइंग टू स्टार्ट कैलकुलेशन? फ्रॉम द राइट साइड. So just opposite to this, we have to take, here we have taken positive, so it will be here negative. This we have taken negative here, so here we have to take positive. So this is regarding sign convention for calculating shear force. Okay, so keeping this in our mind, G पे कौन सा लोड एक्ट कर रहा है? पॉइंट लोड. कैसा एक्ट कर रहा है? कि डाउनवर्ड है या अपवर्ड है? सो यू कैन से डाउनवर्ड है, एंड साइन कन्वेंशन यू कैन सी पॉजिटिव. सो Fg प्लस 2 किलो न्यूटन. ओके, अब आगे बढ़ते हैं. आप देख सकते हैं, आप F पॉइंट पे देखिए, E पॉइंट पे देखिए, यू कैन सी द लोड्स एक्टिंग एट द डिफरेंट पॉइंट्स. सो F पे भी कोई पॉइंट लोड नहीं है, E पे भी कोई पॉइंट लोड नहीं है. मीन्स दिस वैल्यू कांस्टेंट constant up to E. Okay. So अब वैल्यू कहाँ पे होगा? E एंड G के बीच में कांस्टेंट रहेगा. किसका वैल्यू? शेयर फोर्स की वैल्यू. ओके. नाउ सो नेक्स्ट एफ डी. ओके. एफ डी एंड यू कैन सी एफ डी पे मीन्स D point पे you can see there are two types of loads. One is point load and another is distributed load. So D, if I put a minus here, means just before D, means we are excluding 3 kilonewton into the consideration. हम क्या कर रहे हैं? 3 kilonewton को कंसिडर नहीं करेंगे. एफ डी माइनस if I take, okay, if I take a एफ डी प्लस, तो इसका मतलब क्या होगा? ये 3 किलोन्यूटन है, वो आपका कैलकुलेशन में कंसिडर हो रहा है, इंक्लूड हो रहा है. ओके. सो हाउ टू गेट एफ डी माइनस मीन्स जस्ट बिफोर डी. ओके. एंड जस्ट आफ्टर डी मीन्स इट विल बी दिस लोड विल बी कंसिडर्ड. Just before means this load will not be considered. Okay. So आप देख सकते हैं एफ जी पे हमने क्या किए? 2 किलोन्यूटन लिए एंड एफ डी पे देन व्हाट वी विल टेक दिस 2 किलोन्यूटन we will consider. And what about this moment? No, we are not going to consider because we are only calculating the forces. So 2 and प्लस आप देख सकते हैं D and E के बीच में there is a distributed load and it is up to 1 meter. So, and how to get the means how to convert the distributed load into the point load. So यहाँ पे क्या करेंगे हम? Intensity, load intensity multiplied by the length. मान लीजिए load is distributed like a rectangular. So एरिया लेंगे रेक्टेंगुलर का, तो एरिया में क्या हो जाएगा? width and height. Okay. So this we have taken. So this is equal to 4 kilonewton. Okay. Now FD plus because there is one more point load is acting. D पे क्या हो रहा है? यहाँ तक D FD minus 4 kilonewton we are getting. Okay. FD plus then this point load and this distributed load 2 into 1 plus 3 kilonewton load we have to consider. So it will be 7 kilonewton. So what is the significance of this? FD minus FD plus FD minus just before D means this load point load is not considered. FD plus means just after D means this load is considered. Okay. So what is happening here? 4 kilonewton में एक और लोड point load 3 kilonewton load is being added. Okay. FD plus then FC. FC. Okay. So FC now this point load again. Then the moment will not be considered once again. Now what we will do? We will take the total span means 2 meter. Okay, regarding the distributed load. So it will be what? Intensity multiplied by distance 1 plus 1 2 plus this 3 kilonewton. Then it becomes 9 Newton. Okay. FC we have done. Now we have to get app B. App B. Okay. So you can see here app B, here 5 kilonewton load is being added. So here also the same concept, app B minus app B plus. Okay. So app B minus, so app B minus will be what? App B minus will be same like app C. Okay. But app B plus means whatever we have value of app C plus this 5 kilonewton load will be added. So it will be 9 plus 5 is equal to 14 kilonewton. Okay. So this is app B plus means just after B. That's the why 5 kilonewton load is, point load is considered. Okay. What about app A? For getting app A, you can see is there another point load between A and B? So there is no point load, means this value will continue, means there will be constant value 14 kilonewton. App A will be 14 kilonewton. Okay. Now suppose it is asked get the support reactions. So we got the support reactions. This app A itself is RA. Okay, I am writing RA because there is only vertical reaction. So this is a RA vertical reaction. Okay. So by calculating shear force, ultimately we are getting the reaction forces. That's why we have started from the free end, not from the fixed end. अगर फिक्स्ड एंड से करते तो सबसे पहले क्या करना पड़ता, हमें रिएक्शंस फाइंड आउट करने पड़ते अलग से, फिर उसके बाद shear force फाइंड आउट करना पड़ता, थोड़ा सा लेंथी हो जाता. ओके. सो इन दिस वे we can get the shear force values. After this, how to get the bending moment values or moment values? So before drawing the shear force diagram, I am going to calculate the bending moments at different points. Then together we will draw the shear force diagram and bending moment diagram. So here the bending moment calculation. Bending moment calculation. Okay. So कहाँ से स्टार्ट करेंगे? फ्रॉम द फ्री एंड जिसे स्टार्ट करते हैं. सो एंड बेंडिंग मोमेंट को we are going to denote by m. Okay. And g पे क्या होगा? Then m g will be 0, क्योंकि g point पे there is a 2 kilonewton load is acting, but distance means perpendicular distance is 0. That's why mg will be 0. Okay. What about mf? Okay, and MF means moment at F. So here also just before, just after, so just before MF minus, just after MF plus. Okay, so just before means just before means this moment will not be considered. Okay, so now from F, from F 2 kilonewton means this 2 kilonewton load is acting from F means the distance is 1 meter. Okay, and see the sign convention. So once again the sign convention for the bending moment calculation. So if this is the beam and the moments are acting like this, so we take it positive. Okay, if the moments are acting like this, so we take it negative. Okay, so you can see अब F पे सपोज मैंने फिंगर रख दिया, अब देखिए G पे, G will try to rotate it clockwise. So here clockwise, okay, and clockwise we are taking here minus. So MF minus with a minus sign, then 2 kilonewton, and the distance will be 1 meter. So it will be minus 2 kilonewton meter. Okay, and for this MF plus the distance is 10 minus 2 multiplied by 1, then we have to consider the moment, and see, you can see the direction is same like this, means clockwise. So minus 20 we are taking, and then it becomes minus 22 kilonewton meter. Okay, now the bending moment or moment at E. Okay, so E से 2 किलोन्यूटन के डिस्टेंस क्या आ जाता है, minus 2 multiplied by 2, and the moment here we have to consider. Okay, so moment itself is the product of force into the perpendicular distance. So again no need to consider the distance, always remember. Okay, so 2 kilonewton load is considered and 20 kilonewton meter moment is considered. So it becomes minus 24 kilonewton meter. Okay, now am E, sorry am D, E का हो गया D. So from D से G का distance and means load multiplied by this distance, so it is 3. Then again we need to write 20 kilonewton. Then this load means distributed load. So firstly intensity we write, then we multiply by the distance, then this is the point load. Okay, and where it is acting, so D से E के बीच में means it acts at the center, means 2 by 2. Okay, so in this way we get minus 27 kilonewton meter. So MD, up to MD we got. Now I need to omit it because we have a space constraint. So MD we got MD, what we got? We got minus 27 kilonewton meter. Now MC we have to get. So it will be what? From MC, C say you can see the distance of 2 kilonewton. It is 1 plus 1 plus 1 plus 1 means we need to multiply by 4. Then this moment 20. Then now you can see before that we calculated MD, but now we are calculating MC. So the distributed load is distributed up to 2 meter, means at C, from C to E. So that's why now what we have to do, to the intensity, load intensity and the full length, the distributed load, distributed length 2 kilonewton, sorry 2 meter we have to consider. Then when it is acting from C, so obviously कहाँ पे act करेगा? D पे, so 2 by 2. So MC in this way we are getting, okay. And one more thing, MC, yeah, it's okay. This force also we need to consider. We need to consider 3 kilonewton from C. So that's why we have to multiply 3 into 1. So it becomes minus 35 kilonewton meter. Okay. So what about MB? MB. So from MB, 3 minus 2 multiplied by 5 meter, then 20, then 2 multiplied by 2, the distributed load, and from B. So what we have to do? This 1 meter plus the midpoint means 2 by 2. We need to consider. And this 3 kilonewton, then 3 multiplied by, B say you can see multiplied by 2. Okay, so it becomes minus 44 kilonewton meter. And what about MA? MA is equal to, C say 2 kilonewton minus 2, and total length will be 6, 20. Then this load, distributed load, 2 multiplied by 2, then A से C तक का distance क्या है? 2, and midpoint of CD it will be 2 by 2, and this load we have to consider 3 multiplied by 3, and also this load we have to consider 5, and A से कितना distance पे है? 1. That's why 5 multiplied by 1. So we are getting here minus 58. Minus 58 kilonewton meter. Okay. So here you can see MB, MA and MA. This is the resisting moment. Okay? So by the calculation, from the calculation of the bending moment, we got the resisting moment. Means from the shear force calculation, we got the reaction force. From the bending moment calculation, we got the resisting moment acting at the fixed point. Okay. So in this way, now we have calculated the shear forces and the bending moments at each point of the beam where loads are acting. Okay, so MD, once again MD हो गया, MC, then MB, and MB here you can see in the bending moment MB, simply we are not writing plus minus, so MB means this load is not considered. Okay, MB means up to only right side forces are or the moments are considered, but MA, okay, in the MA calculation this load is considered. That's why minus 5 into 1. So in this way simply we can get, if we compare the previous method, the sectional method, so that was lengthy, but it is very easy and we can save our time. Now it's the time to draw the shear force diagram and the bending moment diagram. So what you have to do, you just draw the load intensity diagram. This is the load diagram. Okay, this is the load diagram, and just below, so this will be A, this will be B, this will be C, this will be D, this will be E, this will be F, this will be G. So just below you have to draw the SFD, shear force diagram, and just below this you have to draw the bending moment diagram. So shear force diagram कैसे बनेगा? For that we have to follow the load diagram. Okay. Now G पे हम देखते हैं what was the value of FG. It was 2 kilonewton. Okay. So 2 किलोन्यूटन का हमने एक जंप ले लिए. ओके, एंड 2 किलोन्यूटन कहां तक कांस्टेंट था? सो इट वाज कांस्टेंट अप टू E. व्हाई? बिकॉज देयर इज नो द अनदर पॉइंट लोड इज एक्टिंग, जो वट एवर द मीन्स load is acting in the form of moment at F, which is not considered for the shear force calculation. Okay, so that's why this value will be constant. This value will be constant up to E. अब E and D के बीच में क्या, what is happening here? So D and E, what is happening here? So what we are doing, this 2 kilonewton load is being considered, means the intensity is now being converted into point load. How? By multiplying the distance. Okay, 2 into 1 means this is like a x. 2 multiplied by x means what we get? We will get the linear equation. Okay, so what was the value of F E? The value was F E, it was F E up to it is constant. Okay, but F D, what was the value of F D? So F D minus it was 4, and FD plus it was 7. Okay, so FD minus 4 and FG 2 kilonewton. So what is happening here? Here 2 kilonewton का एक जंप हो रहा है. ओके, 2 kilonewton का एक जंप हो रहा है. सॉरी, not in this way. Okay. F E F D means sorry, I'm going to correct it. Whatever jump is there at the D point, not at the E. Okay. So D at D minus 4. At D minus 4 means यहाँ पर 2 हो गया, तो ये हो गया आपका, this will be 4. Okay. Now from here to here, we will get the linear equation. Okay. And you can see FD plus is equal to 7. 4, then FD plus 7 means due to this point load, क्या हो जाएगा? It will be added. And this will be 3. So 4 plus 3. Okay. And what about FC? FC we are getting 9. So this will be from here to here, it will be 9. So क्या करना है इसमें? Again the linear equation we are getting. That's why what we have to do, this and this will be the linear equation. Okay, means linear line we will get, means the loads are varying. Okay, what about C and B? There is no variation, no point loads are acting. Okay, so this is the FB. Okay, so FB here we are getting FB is equal to 14. Okay, so whatever jump will be here, this will be jump. Okay, so 9 plus 5, and this will be again constant up to A, and we are going to close it. So this will be 14. Once again, the how to get the shear force diagram. So G point पे क्या किए हमने? G point पे सबसे पहले what was the value of Fg? तो G का वैल्यू कितना था? 2 था, and it was positive. That's why पॉजिटिव डायरेक्शन में हमने क्या किया? एक जंप ले लिए 2 किलो न्यूटन का स्केलिंग करते हुए. ओके, अब this value will be constant up to E. Why? Because there is no another point load or another loads are acting in between E and the G. Okay, that's why it is constant up to this. Okay, now what about D and E? So there is a distributed load, and the distributed load, how to convert that into the point load? So what we do, the load intensity will be multiplied by the length. Okay, so means the linear equation we are getting, that's why the linear curve will be there. Okay, so E and D, you can see the variation is linear. At D, 3 kilonewton load is being added. That's why there will be jump. ठीक है, and this is the point load. That's why ये क्या हो जाएगा? उसी पॉइंट पे ऐड हो जाएगा, उसी पॉइंट में आपका ऐड हो जाएगा. ओके, and now C and D again the distributed load. That's why what we got the C FC, that was the 9. So ये linear equation हो गया. Now B, and between the B and the C there is a no load acting. That's why the curve is constant. Okay, and at B 5 kilonewton load is being added. So there will be jump of 5 kilonewton. So 9 plus 5 is equal to 14. This is the shear force at point A. Also this is the reaction force. Okay. So in this way we have drawn the shear force diagram. Now it's a time to draw the bending moment diagram. As we know that the values are negative, so it will be drawn below. That's why this the beam we are taking very close to the whatever we are taken for the shear force diagram. So this is bending moment diagram. Okay. So what was the value of moment at G? Obviously it was 0. So it will start from 0. Okay. What about the value of F, MF, MF, MF minus, it was minus 2. Okay. So whatever the variation will be here, MF minus, it is up to here. Yeah. And this will be what? This will be, the magnitude will be 2. And MF plus is what? MF plus is equal to minus 22. तो आप देख सकते हैं एक ही पॉइंट पे MF माइनस MF प्लस, एक पॉइंट पे जहाँ पे माइनस लिए हैं -2 है, जहाँ प्लस लिए हैं -22 है. मीन्स जंप कितना है? ड्यू टू दिस 20 किलो न्यूटन मीटर देयर इज ए जंप. ओके, दैट वी विल शो, क्योंकि एक ही पॉइंट पे है, दैट्स व्हाई वी विल शो लाइक दिस, एंड दिस विल बी ऑफ 22. IMF मीन्स 22 हो जाएगा यहाँ पे. This will be 22. And what about ME? So ME is equal to minus 24. We have calculated it. So, and what about the curve will be E and F? So in the case of shear force, whatever the constant, that will be now linear. Why? Because for getting the bending moment equation, or you can say the moment, we need to multiply with the distance. That's why E point pe, what is the value? This is the 22. This is the 24, sorry, 24, and the relation will be the linear. Okay. What about D? D pay. So value was 27. Okay. And D and E. What is happening here? You have to refer the shear force diagram. So shear force diagram, you can see from left to right we have to see, and from here to here the value is positive, the shear force value is positive, and the load is decreasing. Okay. So for in this case what we have to do, shear force is positive and load is decreasing. From D to E, load is decreasing. So what we have to do? We have to consider the curve like this. Okay. So that's why we have to consider the curve like this. Okay. And what about the value of C? MC, it is minus 35, MC 35, 35. Okay. Again, this will be like, what about the value of MA? A पे bending moment was what? Sorry, उसके पहले B भी है. What about at B? At B it is 44. At A it is 58. 58. Okay. And what about the, अब देख सकते हैं यहाँ से यहाँ तक A to B and B to C constant. Shear force diagram, the curve is constant, so whatever will be constant here, it will be taken like the linear. Okay, so in this way now we got the bending moment diagram. Once again explaining this, at G, why it started from 0, because mg was 0, moment at the free end will be 0. Okay, and what about F? F पे क्या हो जाएगा? F पे आप देख सकते हैं whatever the moment was generating, so this 20 kilonewton moment is again added, क्योंकि डायरेक्शन सेम है. ओके, सो ये क्या हो जाएगा 20 किलोन्यूटन का उसी पॉइंट पे, एक पॉइंट पे ये आपका इंक्रीज हो गया मोमेंट. ओके, नाउ E and F आप देख सकते हैं, यू कैन सी E and F, द shear force diagram, द curve was constant. जो कांस्टेंट रहेगा यहाँ पे क्या हो जाता है आपका लीनियर कर्व हो जाता है. ठीक है, और डिस्ट्रीब्यूटेड लोड क्या हो जाएगा, ये आपका पैराबोलिक. ओके, सो दिस इज द लीनियर and these two parabolic. Again here linear curves. Okay, so in this way we have done the shear force diagram and bending moment diagram, and because the beam was loaded by multiple forces, that's why it took this much of time, and we have done it. It is very easy. If any problem, you can please let me know. Thank you.